So welcome, everybody. Thanks very much for attending our session today. My name is Denny Lee, and...
Hi, I'm TD. I'm a software engineer here.
Oh, yes, I'm a developer advocate at Databricks. So we're here to talk to you about Delta Lake 2.0. The slides will be available, by the way, for you to download afterwards, so you do not need to take pictures. You're more than welcome to. I'm not stopping you, just saying that's what you're here for, that's all. OK, so I realize almost every single Databricks presentation is going to have that slide, OK? Now, the reason we still have the slide isn't just because we're a bunch of marketing folks, all right? The reason we actually have the slide is because we want to remind the fact that when it comes to lakehouses, one of the key fundamentals behind it is the ability to have reliable data storage. And because you need reliable data storage, that's why you're here talking about Delta Lake, because that's what we provide. So that's the context. You cannot actually have a lakehouse without reliable storage. Okay. Now, in terms of Delta Lake itself, obviously, it's not just about Spark, right? We also talk about the fact that it runs on Flink, Presto, Trino, Standalone, and we also want to talk about the Delta community today. All right, so I skipped that. Now I can skip that slide for you guys, okay? All right, so if you by any chance missed the day one keynotes, first things first, please watch them, okay? Michael Armbrust will explain this concept far better than I can. But the context is that there's been 3 phases of Delta Lake, basically starting around 2017. We actually had Michael and Dom Brzezinski last night at 2 different happy hours and meetups talk about the genesis of Delta Lake. Basically, long story short, Michael noticed the fact that there were jobs failing in our Spark clusters at Databricks. At the same time, Dom himself was saying, I have all of these problems when I'm trying to process the cybersecurity logs within Apple. 2 got together during Spark Summit 2017 to discuss, hey, what's the best way to solve that? And what it came down to was the 2 major things. One was that we need ACID transactions at a data lake. The second thing was their I'll put it mildly, disdain for the Hive Metastore, okay? Yes, it's a very handy system, but the problem with the Hive Metastore in general is that it's not very scalable, okay? So in 2018, that's when both Dom and Michael went ahead and went on stage to announce, hey, we have Delta Lake. Yes, we're happy about it. Okay, guess what, though? We made this a Databricks-specific product, but then we recognized, talking to the community, that this was not just specific to Databricks. This is specific to anybody that was not even necessarily running like internet scale Spark. You could just be running Spark normally. If you decide to have 2 jobs that we're going to try to write to the same table at the same time, you're going to run into the exact same problems. So in 2019, that's when we decided to open source it. Now, that's great, except we, Databricks, made it a little bit confusing for you, okay? And what we did was we said, here's Delta Lake, we've open sourced it, but we also created some really cool performance features, but yeah, we kept it as within Databricks. So what did we announce on day 1 keynote was that we're done. To remove any and all confusion, every single feature of Delta Lake is being open sourced, okay? So all the performance features, and so that's what we're discussing right now today. TD is going to go ahead and review some of the major features that we have for Delta Lake 2.0. The release candidate actually went out on Tuesday, so please test it up now. Now to you, TD.
All right. So yes, what I'm going to talk about today, is what is in Delta 2.0. And actually, it's not the awesome features that has been coming in and it ended up in 2.0 is not just only in 2.0, but in the previous features as well, because we have been gearing toward this 2.0 movement for the last 6 to 9 months. So in the Delta 1.1, 1.2, 2.0, there has been a whole slew of features leading towards that. I'm going to cover only some of them. For the rest of them, look at our release notes, docs, etc. So one of the really heavy performance feature that we added in actually Delta 1.2, but also has matured more in 2.0, is data skipping via column stats. So let's start with what is column stats. So what we do in Delta is that for those who are familiar with Delta, Delta ultimately writes out individual files as Parquet files. So when we write those files out, for every column, we keep track what is the minimum and the maximum value of present in that file for that column. So for every column, we maintain this min-max. And we record this as part of the Delta transaction log. How does that help? When you're doing a read query, let's say you have a filter. Say, for example, the example on the screen is that year equal to 2020 and some UID equal to something. So when you have a filter like this, where you're looking for a specific value, you can just simply, even before reading any of the Parquet files, just at the time of planning the query, you can check the column min-max of every file for that column that you're interested in and see, is this value, let's say year 2020, going to be present in this file or not? If not, then why read it at all? So right at the time of planning the query, we can eliminate a lot of files, skip over them, and not read them at all. So for queries with filters, this can reduce the amount of data actually read, and therefore amount of computation, and therefore cost dramatically. Now, the interesting bit is that for those who may be familiar with Parquet row group skipping and skipping in just bare bones Parquet files, that has been there for a long time. This is much better than that, because even with Parquet row group skipping, you have to still launch a task to open the Parquet file, read the footer, and then find out the min-maxes of the row groups and stuff. Here we eliminate all of that. You're not even touching the file if that file doesn't have the data you're looking for. But to take this to the next level, what you really need is you need to ensure that every file has a very small range of min-max values. For example, if, let's say, your data is organized such that every file has data between 0 and infinity, you just can't skip any file. You're looking for 100, whereas every file contains data from 0 to infinity. What do you skip? So to really take advantage of this column min-max, you need to have your data clustered within your files. And to do that, we have this operation called optimize z-order. Again, it was there in Databricks Delta for a long time. Now we have open sourced it. What it does, it's basically a fancy form of multi-column data clustering. Now, to put it in contrast of what this is, if you have a query which is filtering by one column, you would say sort the entire table by that column, which is great. It's easy to find. But the moment you have something like, let me go to the next slide, I'll go back and forth. If you have a query that is of the form where you're filtering by two columns, x equal to 2 or y equal to 3, then just a linear sorting doesn't help that much, because you're still reading a lot of files. If you sort by x, you're still reading a lot of files for finding that one value of y, because the value of y is like unclustered in the files sorted by x. So that's where things like z-order comes in, because instead of sorting it linearly, it has a crazy different pattern of sorting. You'll see the pattern of, I hope it's visible on the screen, but you'll see the pattern of arrows, which forms like a z. That's why it's called z-order. But this is z-order is one of the entire class of such sorting and clustering algorithms called spatial curves, space filling curves in database literature, that allows you to sort data in this crafty way across multiple columns, which results in the same query reading much less data. When they have filtered on two columns or more columns, it's reading much less data than linear sorting. The awesome thing about z-order, if you compare this with the old school partitioning, is that when you partition a table, you are fixing you cannot change the partitioning of a table without actually rearranging the entire table. However, with z-order, you're not restricted by that. You pick which columns you want to z-order by based on your read query patterns, what columns are you filled mostly by and stuff. And if that changes, you can very easily z-order your data in a different layout. And you can do it either at an entire table or even within partitions. So each different partitions can have different types of z-order. For example, here's a common example where you have data coming in through days, months, years, and a common pattern is partitioning the data by date. And now often we see that the kind of queries that are going to be done on 1 year ago data and the kind of queries happening on last 1 week of data are very different. So which means that the partitions of that are 1 year ago data can be z-ordered by a different set of columns than the partitions, the newer partitions of last 1 week of data. So this gives a lot of flexibility that partitioning doesn't give. It allows your tables data layout to evolve with your read query patterns. A very quick example is here's a table, a half terabyte table from the TPCDS 3 terabyte data set. To kind of show how optimized. By the optimized, there's two flavors. There is compaction and there is z-order. I talked about z-order, but there is also the compaction, which compacts small files. To show the impact of that, here I took a half terabyte table that had 40,000 files of around 13 MB each. If a simple select count with a filter query took some amount of time. That's the left-hand side baseline. Guy ran optimized compaction. It compacted into larger 1 GB files. The query went down, but the data was still unsorted, unclustered. So I ran z-order based on that one column in the query, and the numbers dramatically went down further because it eliminated more than 95% of reading, 95% of the data without even touching the files. Moving on. The other major feature this came out actually now in Delta 2.0 is change data feed. And before I get into the details of what change data feed is, let me talk about the motivation behind why we build this. So it's a very common workload pattern where you are getting changed data from external system. Let's say you have a MySQL or some kind of OLTP database, transactional database, which is doing row level changes very quickly. Is it low battery?
Yeah, it's a little better.
It says 39 minutes. Let's see if we can finish this.
All right.
Well, we have to finish that before that.
Oh, yeah, we're fine.
We're good.
Yeah,
we're good.
We're fine.
Okay. So where was it? Yeah, you have changes coming from an external OLTP system. They want to, customers want to take those changes, apply it to OLAP style database files and stuff so that they can run analytical queries on it without affecting without putting pressure or load on the transactional database. So this sort of thing is very common, and the way people do it is that they take the row level changes from the change log and apply it in a continuous fashion into OLAP database, hopefully with files and stuff for large scan performances. And then they want to propagate the same row level changes through more and more refined set of tables. One way to look at it is the classical medallion structure of bronze, silver, gold tables and stuff. But people want to build end-to-end incremental pipelines all the way, that operates all the way through incrementally without reprocessing the entire data at every step. Now, what Delta provided till now was, whoops, I guess this also started failing.
Okay, well then.
Oh boy. There we go.
Okay, at least that works.
Yeah, okay. Let's see.
It's okay. We should be okay.
Thank you.
Thank you, yes.
So what Delta provided till now, for actually a long time, is the merge operation, which is an absolutely fantastic operation, especially the way Delta implements it, because it has one of the most advanced merge syntax in any system. We built the merge and the proposed advanced syntaxes first, added it to Apache Spark so that other systems also can take advantage of it. But the cool thing is that it provides both advanced syntax in Scala, Python, APIs along with SQL, which again, very few other systems do. At least to the best of my knowledge, no other system does that. The other thing that the merge provided is automatic schema evolution. So you have your change data coming in, and your change data can be, your downstream system that is generating change data could be automatically updating the schema and stuff. And you want those schema changes to be applied automatically to your OLAP database as well. So using merge, you can actually automatically evolve the schema in a safe way while applying those changes and stuff, which is, again, a fantastic feature. You should try it out. It makes life really, really easy. One of our most popular features. Anyways, no more about merge. I digress. The important bit here is merge is in Delta is awesome, but it also has the way merge operates underneath at the file level is this technique called copy on write, where in order to modify a single row in a file, you have to rewrite the entire file. Now, we are working on how to improve that, reduce the write amplification using deletion vectors. I will not get into that right now. But the problem that, one of the problems that the user had with this is that if you want to apply those merged changes into a delta table and you want to propagate those row level changes downstream, you cannot, since delta did not track what are the rows that changed, you could not read only those changed rows and propagate them downstream. So that was like a other side of the coin that was missing. That's why we introduced change data feed, where well, there was ways to deal with this by comparing the joining between two versions of the table to find out what changed, which rows got deleted, which rows got updated and stuff. But that was also obviously inefficient. So what we built with this change data feed is that the merge, or for that matter, update, delete, all the DML operations doing row level changes will write out the changed rows in additional set of files at the same time as writing out the main files. So the nice thing of this model is that if you are interested in reading the actual data, it is still optimized in separate set of files as before. So it is things popping up on my screen.
Yeah.
Just click on the PowerPoint. I think it should be fine.
Yeah, hopefully. No. All right, we also have 10 minutes, 12 minutes, so yeah.
Okay, let me speed that up.
Yep.
So the cool thing is that it is very efficient. If you want to read the actual data, it is in a separate set of files, no filtering needed, read it efficiently. If you want to read the changes, it is in a separate set of files. Again, no filtering needed, you can just read that. And you can do that either using streaming, batch, or streaming APIs, so you can truly build end-to-end incremental pipelines using that, or you can interactively query what changes happen between this time and this time in this table. Moving on, the other big project we have been working on is this project called column mapping. So kind of the problem Delta had till now is that Delta, in a Delta table, the logical name of a column was also what is used by the Parquet files as to store the data, which limited us in two ways. One, Parquet files, Parquet format did not allow certain characters in their column names, like commas and semicolons and stuff, which is a limitation that is tied to Parquet file limitation, but ideally should not be there. The other problem is that there was no way to rename columns without actually rewriting the entire Parquet file with a different column name. So renaming and dropping columns was not supported until now. So what we did is with this column mapping project, we introduced a simple indirection, a mapping between the logical name of a column and the physical name by which it is written inside the Parquet file, which allows us to overcome both of those problems. You allow arbitrary logical column names without any restriction on what characters are supported, but internally it maps to clear, uniquely identified names, physical names, UIDs and stuff, which is Parquet format compliant, and so it doesn't have the restriction. And the renames become just a logical change in that mapping. The new name just points to the same old physical column name. No need to rewrite the Parquet files. So Delta 1.2 introduced support for column renames and arbitrary column names not restricted by Parquet limitations, and Delta 2.0 added support for dropping columns. The other cool feature, again, I'm going to rush this. Please talk to me right after this or look at our blog and docs about this. But one of the major limitations Delta had only for S3 is that Delta relies on the file system providing transactional guarantees that you can write a file only if it is absent. If there are two concurrent writers trying to create the same file, only one of them should win. This was there for Azure and GCS and other file systems, HDFS and other file systems out of the box. S3 did not have that. So in S3, when two Spark clusters would try to write the same file, both of them will succeed, therefore overwriting each other's changes, which is exactly what you don't want if you want to provide asset guarantees and stuff. So to overcome that problem, what we introduced is this another indirection where instead of using S3 as the transactional system, we use DynamoDB as the transactional system, where instead of trying to commit, put a file only if it's absent in the file system, we try to put a key, the version in the DynamoDB only if it's absent, which is like the exact feature that Dynamo gives out of the box. And so we first commit to the DynamoDB, which ensures a serializable order that one writer goes after next. And after that, we save that information, sync it back to S3 so that any reader looking at the file system can sees a consistent table and not dependent on DynamoDB only. So that's what we do. The good thing is that this solution does not require distributed locks, distributed leases, or doesn't depend on any self-managed service. It just works out of the box as soon as you configure Spark with these two configurations that use DynamoDB, and here is the DynamoDB table name and details and stuff. As soon as you configure that, everything just works. Okay, many more features are there. I'm not going to cover them. In the interest of time, handing it back to you.
Thank you very much.
About how, actually, I did not cover Flink, so. Okay.
Oh, okay, yeah.
Okay.
All right, we've got, try to see if we can.
Yes, okay. Clearly, we had more information than we could talk about. So, TLDR, we have been expanding it not beyond Spark to Flink. We have the Flink Delta Sync already out. Please try it out. We will have Flink Delta Source out very soon. Both of them have the same level of support and APIs as the Spark streaming and batch support. We also have already released the Trino and Presto Delta connector. Again, so we have expanded the system, and we continue to expand the system to much more newer and newer processing engines. The one key thing to remember is that a lot of these systems are built on this project called Delta Standalone, which is a simple Java library unrelated to Spark that allows you to read and write the Delta log from a single JVM. And all of these Flink, Presto, Hive, all of these connectors are using Delta Standalone to do that processing. Cool. On to you.
All right, perfect. So in the less than 5 minutes, the key call out that we want to talk about is that all of this was actually possible because the Delta community. So when I go backwards and talk about just the expansion, we have things like we talked about Flink, Presto, Trino. This actually happened because we had help from the community. Okay, this is not something that just came from people, us up here. Okay, the S3 multi-cluster write came from Samba TV. The Delta Rust one came from the script back market folks. Okay, so we actually want engagement by the community because that's actually how we're going to be able to expand Delta Lake. This graph here that was shown, a version of this was shown during Michael's keynote, basically notes the fact that when we started about May of last year, May of 2021, we've had about 650,000 downloads. As of May of this year, 7 million downloads. And
yeah, I think it is late. I mean, we generated these numbers 2 weeks ago. I think it's already more than 8 million, close to 8.5 million, because in the last 2 weeks itself, our PyPy downloads of Delta on Spark has gone up by more than 1 million.
But the reason why is because you can tell each month we're actually having various additions, okay? Whether it was Flink, whether it was the Python bindings, Delta sharing, Presto, Trino, whatever else, right? We have a lot of activity by the community to help improve the Delta Lake project. So it is not just about Spark. We want to make it very clear, right? Yes, it obviously was rooted in Spark, but it's certainly not just about Spark. And we couldn't do this without the community. These logos are developers from these organizations have helped us with it. More than 70 different organizations, developers from more than 70 different organizations have actually been helping the Delta project since its inception. So we really would love your support as well, right? Obviously we want you to use it, but we also want you to go ahead and actually help contribute to it. And we're very active in the community for that. We have 6 different repositories right now, and we're probably going to have more, by the way, at the rate we're going, because we have different repositories because we're all operating at different speeds, and we want you to operate at different speeds. We don't want you to be limited by one particular project. The Kafka Delta ingest was running at a much faster pace because they basically were able to get Kafka topics down to a Delta table using the Delta REST API. They basically went in production in 3 months, okay? Pretty fast. So these are some amazing things that the community has done and come together, okay? In the interest of time, let me just jump to this point. How are you gonna help us contribute? Well, with any of those 6 repositories, refer to the good first issues. Okay, we have a tag in there. And so you go ahead and just literally look for that tag, and you can help us there. Whether it's website stuff, documentation, to hardcore development. For example, we have a bunch of people, I think I see you in the audience, who are interested in the Golang developer. Golang Delta connector, absolutely. These are things that we would love to have help with. Engage with us. Go to Delta user Slack. Specifically, there's even a contributors channel that you can go ahead and ask us questions there. And then, of course, Delta.io, Delta.io, the website, where we provide all this information. And so that's the best way of how you can help us contribute. And for that matter, for example, this actually literally came out by the folks called DataBeans out in France. They actually were comparing the 3 data storage formats between Delta Lake, Hudi, and Iceberg. The key context is they did it without our involvement at all. Okay, we didn't ask them to do it. They decided that they wanted to test it, and it showcased how much faster Delta Lake was against Iceberg and Hudi, right? Pretty cool numbers, right? These are examples of how you can help contribute. And then finally, this is how you join us, okay? That slide, if you're gonna take pictures, that's the slide you wanna take pictures of. But basically, go.delta.io. If you wanna join us at GitHub, go.delta.io GitHub, Slack, go.delta.io Slack, and of course, Twitter. We also have LinkedIn. We also have a YouTube channel. So there are many different ways to go ahead and interact with us, okay? So saying that, I think that's it. Yes, that's it for our slides. We still have 2 minutes, so we'd love to answer any questions. We're gonna make sure we end on time though, but we'll be on the side for us to ask questions as well, so. All right? So, shoot, any questions here? Go for it. Because Delta Lake, okay, sorry, to repeat the question, sorry, I just forgot to do that. Is there commercial support for Delta Lake itself? Just like Spark, okay, and MLflow, it is a community-based support mechanism, right, because these are open source projects. Databricks will be supporting, for example, its own instantiation of Delta Lake. For that matter, any of our the companies that also offer Delta Lake, they'll be talking about supporting their own versions. But in terms of Delta Lake itself, yes, it'll be primarily community support. But as you can tell from, like, for example, our pedigree with Spark and everything else, we're pretty active on answering questions like that. So hopefully that helps. Yes. Any other questions?
There's one over there and one over there.
Okay, perfect.
Oh, there's one. Wow, a lot of questions.
Mapping, does that cause any compatibility issues if you're reading it just as a Parquet, or just with like the UIDs, and is that in the manifest file?
Repeat that.
Yeah, okay, so the question was that with the column mapping project, now that we're separating their physical names from the logical names, does that cause any compatibility with while reading them as Parquet files? The answer is yes. Of course, you cannot, if you just try to read the Parquet file by itself using the manifest approach, you will see UIDs as column names. You will not have the logical columns in there because the logical column name information, that mapping is in the transaction log. So yes, the manifest approach will not work if you have enabled column mapping on a table. The good thing is that it's not enabled by default exactly for these compatibility reasons. You will have to set a table property in order to make sure that you upgrade the table's protocol version to the higher level while being aware that these are the few other things that can break, and so be aware of that. No. You can do that at any point of time in the table. So it's a completely opt-in feature.
All right, sorry, I apologize. I know you have other questions. We want you to ask us aside. We want to be cognizant for everybody else. So thank you very much for attending our session today.
Cool. Thank you.